Welcome. I'm Giovanni Zanalda, the director of the Duke Center for International Global Studies and of the Rethinking Diplomacy program. Welcome to the webinar Beyond Talking Points, the Crisis in Space, the Future of Space Diplomacy. Today, we have the honor of having three great speakers, and Professor Britt Lundgren will moderate this discussion, and she will introduce Ambassador Pearson and Dr. Schmitt. I would just to say that I would like to send a thank you to Professor Lundgren, who is a professor of physics and astronomy at the University of North Carolina, Asheville, and she's the chair of the advisory board for the North Carolina Space Grant. This webinar is part of a series on space diplomacy that the Rethinking Diplomacy program is going to organize in the future. So we hope that you will learn something from this first webinar and that you will follow us in the future. Professor Lundgren, thank you very much.
Thanks, Giovanni. I'm happy to be here. I'm really pleased to be able to introduce to you the two panelists who will be speaking in today's discussion. The first is Ambassador W. Robert Pearson, who is currently a program fellow of the Duke University Center for International and Global Studies Rethinking Diplomacy program. Prior to this role, he served as U.S. Ambassador to Turkey from 2000 to 2003. Following that appointment, he became the Director General of the U.S. Foreign Service from 2003 to 2006. Following that, he was president of IREX from 2008 to 2014. He's also joined by Dr. Benjamin L. Schmitt, who's a postdoctoral research fellow and project development scientist at the Harvard-Smithsonian Center for Astrophysics. Dr. Schmitt is also a program fellow in the Rethinking Diplomacy program at Duke. He also serves as a senior fellow for democratic resilience at the Center for European Policy Analysis, and previously served at the State Department as a European Energy Security Advisor from 2015 to 2019. So thank you both for being here today. We're running today's event in a webinar format, which means that we will be taking questions from the audience following a brief introduction from both of the panelists. You're invited to put any questions that you have into the Q&A feature, and I will relay them to the panelists for discussion. But to start off today, I'd like to begin by asking Ambassador Pearson to spend some time defining the topic of space diplomacy. Maybe you could introduce the historic, diplomatic, and legal context for this field.
Thank you, Britt, very much. I'm delighted to be here this morning, everyone, and I'm sorry that we can't do this face-to-face, but we will one time. And today I'm extremely happy that a large number of you have decided to participate in our talk today. So I'm going to talk about four things, actually, very quickly. One is the history, then the law. I'm going to mention a couple of complications, and I'm just going to allude to possible broad kinds of solution sets, really in order to generate questions. Diplomacy is the art of finding agreement among contending and competing interests so that the threat of conflict, war, or excessive damage to society is avoided. It's as old as human history, it's as new as this morning, and so that is the endeavor that I've spent my professional life working on, and which I'm happy to try to share with you today. So in talking about history, I ran across a quote from Mark Twain, allegedly a quote from Mark Twain, in which he said that history doesn't repeat, but it often rhymes. And this time history is rhyming. In the 15th century, the beginning of the age of European exploration of the world, there were three factors which emerged, which really controlled the process for the next 5 centuries. One was that the access to the space, that is, ocean-going states at that point, had a predominant role to play in the outcomes. Secondly, the conflict over resources took place often in foreign territory, but the consequences were felt at home. So wars that were not confined to extraterritorial locales, but came home to Europe itself. And thirdly, the role of private enterprise was a very important component. The Dutch East India Company was the largest corporation in the world in the 17th century and dominated a great deal of its trade. The British East India Company controlled half of the world's overseas trade in the middle of the 18th century. We're seeing all three of these phenomena reappear. And the truth we draw from diplomacy is that unmanaged competition leads to conflict. That's what humans do. And therefore, managing the competition is key to maintaining a safe and prosperous environment. Excuse me. Now I'm going to talk about the law a little bit. And just to be precise, I'm going to look at a couple of references. The Outer Space Treaty is the cornerstone of the legal regime controlling activities in space. And basically, it does two things. It commits countries not to place in Earth orbit or on the surface of the moon or any other celestial body or in outer space nuclear or other mass weapons of mass destruction. That's the first principle. And secondly, it limits the use of the moon or other celestial bodies exclusively to peaceful purposes and prohibits on them military bases, installations or fortifications, testing weapons of any kind, or conducting military maneuvers. It's an easily read treaty. I recommend that you look it up and read through it and understand what it says can't be done and what it says can be done. That was negotiated in 1967, and in the 50 years plus intervening, it has shown that there are gaps and things that we have to address. And we'll do that in answer to your questions or in further commentary later on. The couple of contradictions I want to just point out. The treaty does not regulate the use of conventional weapons in space. And this is a growing issue, and without trying to detail it, it is a gap that has to be addressed. And secondly, it does not regulate the activities of private enterprise and private companies in space. And there again, if we're looking back at the 16th century and 17th century, we again have a model for what happens when unbridled competition takes place around the globe. And in this case, both of the companies I mentioned, the British and the Dutch, ended up with their own armies to protect their interest. In human history, military force often follows economic interest. And so that is why that contradiction has to be addressed in some form. The final point I want to just leave with you is a generalized approach forward. One is to develop norms of behavior where treaties are unlikely to be negotiated in any foreseeable future. And my own choice is that applies to space debris in Earth orbit. And there are any number of things that could be done that would create what we call transparent and confidence building measures, TCBMs, that might help frame the norms of behavior that would guide us. Secondly, the Outer Space Treaty is, from its origin, an arms control treaty. And so in some way, in some form, and in some manner, in some timetable, we need to start thinking again about the arms control aspect of the uses of outer space. And then thirdly, I'm going to draw your attention to the latest NATO communique, especially paragraph 33, and the support of the European Union as a kind of complex that would allow us to begin to form an international consensus, not to exclude the Chinese, not to exclude the Russians, but to have the 30 countries of NATO, the 27 countries of the EU, our other allies, Japan, South Korea, Australia, form a very powerful group of countries with similar interests that might be able to begin to create a framework for future cooperation in space that would manage the competitive atmosphere that is growing every day. So with those brief remarks, I will conclude and look forward to my good colleague Ben Schmitt's comments. So thank you very much.
Thank you. That context was extremely helpful. Ben, I'm wondering if you could provide some additional information about the current technical kind of challenges, opportunities, and maybe also the threats posed by the increasing occupation of low Earth orbit, the moon, and maybe even beyond.
Thank you, Britt, and hello, friends. Hi, everyone. And I'll just say, because Britt hasn't said it yet, but Britt and I came into government at the same time as two astronomers coming to Washington as science fellows and becoming a part of the science policy process. And so it's really great to be reunited and talking about these sort of issues, because this is exactly some of the most fundamental headline grabbing issues of today. All have some sort of science or technology component to it. When you look at foreign policy, you look at national security policy. I often look, when I'm talking about transatlantic security policy, about how authoritarian infrastructure development here on Earth has specific impacts for the way in which Russia and China have exported elements of authoritarianism, strategic corruption, elite capture, and using economic deals and emerging technologies under the guise of commercial deals in which they are in fact having different readings, whether or not you're looking at this from an economic, a scientific, an engineering, or other perspective. And so that's why, and I'll just say as a top line, and this is really fundamental to our program here at Duke, we absolutely need more scientists and technologists, practitioners of science and technology involved in the mid to senior level diplomatic and national security process in Washington, and need to have kind of a more robust approach to this, whether it's creating new positions or integrating them further, because oftentimes you can look and vet some of these technologies on what their national security impact is or might not be, if something is actually not a major national security concern, and have a science and technology, pragmatic, practitioner-based approach to solving some of these issues. Because when we look at some of the biggest issues, and I focus, as I said, on the transatlantic space, we talk about things like energy policy, Nord Stream 2, for example, the debate between Germany and the US and other European nations on that gas pipeline. We have the debate over 5G and Huawei and China's Belt and Road strategy in Europe. So all of these sort of issues are often looked at as kind of individual pillars of, how are we going to look at and engage on that specific technology or that specific infrastructure. And what needs to happen is a more holistic approach of how these technologies and these investments are actually being manifested to have a diplomatic or national security impact or things like that. So nowhere are we seeing that happen faster or since we're talking about space, in hyperdrive than in space. And the first 6 months of 2021 have really showed us that whether we're talking about low Earth orbit, whether we're talking about deeper space between low Earth orbit and our moon, and whether we're talking about very deep space looking out to Mars, there's different geopolitical issues that are becoming manifest very rapidly, and seeing these technology deployments and developments and dynamics really upend the order that we have seen basically since the end of the Apollo program, in terms of what was once a bipolar space race between NASA and Roscosmos of the Soviet Union, Soviet Union space program, now has a lot of players. And it's not just nation states anymore. Of course, we've seen China get into the game very robustly, but we've seen the proliferation in the past decade, and especially in the past 2 years, of commercial actors, including SpaceX, including others in the U.S. that have been able to really upend the dynamics of what does it mean to be a spacefaring nation, what does it mean to be a spacefaring company, and have those technologies, and what are the knock-on effects? Because as we've seen over the past month and a half alone, 2 months alone, we've seen all the way out in Martian orbit earlier this year, not only the United States and China, but also the United Arab Emirates send probes that were in Martian orbit. And there then 2 landers, a U.S.-based lander and a Chinese-based lander that both landed on the Martian surface. Of course, the U.S. Famously has also launched the first controlled flight aircraft on another planet with its drone its quadcopter drone or helicopter drone that is launched from the Martian surface a number of times. And we've seen the proliferation of the Artemis Accords, which is an increasing group of nations led by the United States to try to start building out the regulatory norms for what will start as the Artemis program to bring humans back to the lunar surface in just a few years, by potentially as early as 2024. So this is just around the corner. And we've seen Russia and China say, the Russians in particular say that they want to join with the Chinese and create their own program. And that's potentially set up this dynamic of a space race, which Bill Nelson, the NASA administrator, has said, we want to avoid a space race. And I think that's the right approach. But I think that at the same time, we are de facto in a space race, but it just has different dynamics because of the number of commercial actors and a number of players, which are really going to put to test exactly those regulatory norms and those international agreements that were written way back starting in 1967 and had corollaries, including the Moon Agreement in the late 70s, that really haven't been put to the test in a real meaningful way, right? There has been no human activity on the moon to test the Moon Agreement because it was written after the Apollo program was completely completed. And then, of course, in low Earth orbit, it's an increasingly complex, in some cases, free-for-all of the sort of technologies, norms, and payloads that are delivered into low Earth orbit, including an increasingly large array or mega constellation of CubeSats that can provide satellite-based internet coverage. And we've seen Elon Musk in SpaceX launch and begin their Starlink program to create satellite-based internet coverage for the entire world. But we see that Amazon's Project Kuiper, we've seen a number of other companies in the EU, as well as China's proposed Starnet service be proposed. And, it's really going to have those sort of, space-based problem sets, which we'll talk about kind of what the technology issues of that are, but also potentially to create the debate between nations on using authoritarian infrastructure versus, infrastructure from democratic nations, and that Huawei and 5G debate really on steroids when you have these sort of systems vying for coverage rights across the whole globe, where they don't actually have to build physical infrastructure on the ground. So that's just a flavor of some of the big issues that we're seeing just this year. And I look forward to the discussion based on that, because I think that from a diplomatic standpoint, from an international law standpoint, and from a national security and defense standpoint, it really needs to be front and center in terms of, since this is a Duke and DC program, in terms of the priorities that we place space and space policy under. because it's no longer science fiction. A lot of these areas, I watched the show For All Mankind, which came out on Apple Plus a few years ago and just wrapped its second season. And it really depicts this alternative reality where the space race never ended, and the US and the Soviet Union have vying moon bases. I mean, I won't have any spoilers, but we're really looking at those sort of science fictions becoming science realities this decade, and we really need to keep that front and center in our focus.
Great, thanks, Ben. I agree. A lot of people probably think of space diplomacy as something of the future, but in reality, we're seeing a pretty exponential rise in the rush to utilize these places in low Earth orbit and beyond. I hope maybe later in the conversation you can address the potential for collisions and what kind of impact that could have on global infrastructure that's space-based as well. So there are many different aspects to these threats, I think. So it occurs to me, with space being kind of a global stage that all of humankind shares, some policy comparisons might be drawn from the kinds of international diplomacy that have been used to define the polar regions and the oceans and their use. And I was wondering if Bob, you might be able to speak to that, or Ben add some ideas.
Sure, absolutely. I'm happy to do so. And you're absolutely right. There are references that could be very helpful. The Antarctic Treaty is the progenitor of the Outer Space Treaty. It was designed, the Antarctic regime was designed to prevent a colonialism-like fight for new territory, and it has largely succeeded. And it was the inspiration for the Outer Space Treaty. So in terms of fundamental apparent of the Outer Space Treaty, largely one of the parents is the Antarctic Treaty System, and the other one is the nuclear disarmament treaties that were reached between Russia and the United States many years ago. So there was an agreement to manage competition while retaining both deterrent, military and political deterrence, and also to provide for the security of the country. So that formula worked then, it's worked in several dimensions, and it's available now. On other issues, on the high seas, we have regimes for avoiding collisions of ships, which are honored. We have the organization of the economic zones, which were designed in the law of the sea to diminish competition. Unfortunately, I think they've exacerbated competition, but there's an example of being able to deal with individual countries' resources, a problem that we're going to have to address. And then I think there's really a connection to the climate change discussions. We're really looking for, and countries have said this openly, we're looking for a sustainable, resilient, peaceful presence in outer space. And that is precisely what we are trying to do right here on Earth. So many of the ideas there of sharing in a common good, even though there are individual sacrifices by countries, it means that overall the benefit is shared. So I think that that's another powerful incentive that people can refer to. And then finally, a small one, look at how we divide up radio waves and microwaves and so on around the world. We have an international agreement that does that, and no one pays it much attention because it does work. So there is a way to divide the spectrum of opportunities and risk so that everybody can benefit and no one can dominate.
Yeah, and I completely agree with that approach and what Bob has said. I will just add and say that when we look at these sort of spaces, whether it's the Antarctic Treaty System or others, the UN Convention on the Law of the Sea, we're talking about the global what's known as the global commons, right? And so we're looking at areas that are, by their very definition, not sovereign, cannot be sovereign by international treaty. And the Outer Space Treaty is set up like this. So it does have a really key corollary to how we've seen the Antarctic Treaty System in particular is a great example develop over the past 65, 70 years or so since it came into force. But there are certain technical realities that become, something that we need to think about. How does that actually work in practice? And part of that is what does it mean for national appropriation? Because we have a scenario in which under the Antarctic Treaty System, as well as the Outer Space Treaty, you can't declare a sovereign territory on one of these areas of the commons. And in the case of the ATS, it's Antarctic territory. In the case of the Outer Space Treaty, it's declaring sovereignty over areas or over entire celestial bodies. But at the same time, now we're looking at kind of a bifurcation, whereas the Antarctic Treaty System specifically says that you can't perform any extractive industries, meaning mining for critical minerals, mining for conventional minerals, mining for hydrocarbons and things like this in and around the Antarctic continent below 60 degrees south latitude. This is not the same in space, right? So you have a scenario in which the Artemis Accords are pointing out that the ownership of the land, if you can think of it that way, on any celestial body, whether it's on an asteroid, on the moon, on Mars, etc., doesn't come under the sovereign rights of a host nation or a company operating from under the flag of a host nation. But at the same time, they have the rights to the mineral resources themselves. So what does that mean in practice, right? So does that mean you are de facto, engaging in sovereign appropriation of the territory on which you're extracting that, if that is, your resource that your company or your country has decided to extract? So that's a big question. That's something that is in the headlines. Is recently as this week, Japan passed its version of those sort of extractives laws at a national level, and it's something that I know the Russians have objected to for this purpose, and it's something that I think that we need to get a handle on. Not necessarily saying that one country is right or one country is wrong, but rather that there needs to be international norms that are put into practice that really look at this. Because what you see in the Antarctic Treaty System is an area of, how do you think about enforcement? It's still a remote area of the Earth, but it is possible, and it is done regularly, to have reciprocity between the various research bases in Antarctica to basically fly in effectively unannounced to do spot checks and to do reviews that any country that's operating in that space is not using it for extractives, for military use, et cetera, et cetera. What does that mean in the space case, right? It's going to cost a lot more, and the technology is at a level where it's going to be a much greater threshold to actually go and perform these sort of reciprocity checks, if we're talking about different bases on the moon and things like this. So those are the sort of things we need to understand and really need to build out these international treaties and regulatory norms, because in just a few years' time, we're going to be dealing with this, whether we like it or not. And that's something that we really need to have in the front and center in the diplomatic portfolio here.
I do need to, add just one factoid. The Trump administration issued an executive order during, I think it was 2020, in which it denied that there was a global or space commons, and said that to admit that would be to fail to support private enterprise. So I think that Russia, China, the US, Japan, perhaps others have made it clear in their national legislation that they will own the resources they find. So obviously a company is not going to go search for something if it can't have ownership of the resource that it uncovers. So the US position has not been overturned by the Biden administration. And so for the moment, it is the US position, and it is a denial of a space commons that is mentioned in the Outer Space Treaty and in the so-called Moon Treaty.
That's right. Absolutely.
Thanks. We're starting to get some good questions in the Q&A, so I want to raise at least one of those. So as a point of clarification, do the existing treaties cover military satellites that are currently in orbit? And what are the potential space-capable entities who are not part of these treaties? And then a follow-up being, what is the actual enforcement mechanism?
Well, there's no treaty that denies the placement of military satellites in orbit. And there is no regime at the moment that regularizes that. The NATO position in its space policy has been very clear. It on 2 points. It says that an attack from, to, or within space is not an intention of NATO. This is not NATO policy. So they've made it very clear that they are against weapons in space, period. And it's in their space policy statement. And the second thing is that there are already counter satellite capabilities that have been developed for space. So I think that the chances are, going back to my point earlier in the talk, there are norms of behavior that could be discussed so that this can be regularized. But I doubt that there is an opportunity to turn back the clock based on what already exists.
Absolutely. And I'll just add that when it comes to these sort of frameworks, you really need to look back to what Bob said, which is, they're based off of international arms control treaties. And that's really what these are. And so we need to treat them in the same way that it's both having these treaties and then verifying them. Because, for example, the Russians and the Chinese have pushed in recent months a resolution at the UN where they want to limit the ability to deploy, for example, on orbit military capabilities, which are abilities for satellites to actually attack or harm or do other sort of activities against other satellites. It's been reported. There's a great foreign policy article on this very topic that the Russians have had satellites that shadow other satellites and things like this. There's been reports of projectiles that have been tested and things like this that are not within they're basically conventional weapons, right? Because you're sending a non-explosive projectile at another satellite, which gets to the point on space junk that we need to talk about desperately. But if they already have these capabilities, one question is, should other countries basically adhere to this and sign up to such a treaty if the progenitors of that treaty are already in violation of it or trying to be grandfathered in? And so those are the sort of things, and those are very old dynamics that have been well worn and well understood in the non-proliferation community in terms of international arms control agreements. And so we need norms on verification that can understand which sort of treaties and proposals, whereas they often sound reasonable, do they actually create an imbalance that is outside of a normal proliferation policy standpoint?
Great, thank you both. We have a question from Ambassador Kenneth Quinn. While military-type weapons in space have been addressed to a certain extent, in the age of information warfare, the question of what constitutes a weapon seems to be new and meaningful. For example, are attacks to, quote, blind communication satellites or cyber attacks on the electric grid or banking systems subjects that can be or are being addressed through space diplomacy?
Yes, that's a very good question. And NATO, in its recent communique, specifically listed cyber as a potential threat, and therefore, obviously, its use as a weapon from we could say from space, but from any source, but including space. So I think that is a question that has to be addressed, and it has to be addressed within the broader context of what we do with cyber. And NATO's position on this is very clear. And in fact, NATO went on to say that those kinds of attacks I just mentioned, from, to, or within, could be considered a violation of the Article 5 promise in NATO that an attack on one country is considered an attack on all. So that's a political statement of significant importance for deterrence. So Ambassador Quinn is exactly right. Cyber is an issue that must be addressed.
There's another question asking whether the existing global treaties are sufficient to govern outer space, or if, in your view, we should be working to negotiate new global treaties.
Well, Ben, why don't you start with your thoughts on that? And I've already said a couple of things, and I'll follow up.
Yeah, I mean, I think that what we're seeing is we do have, and I think that part of the reason that Ambassador Pearson, you're able to say that the Outer Space Treaty is a semi-easy read is that they are very broad statements, broad treaty statements that have been put out that don't have the level of fidelity and detail on specific space contingencies that set out the rules of international norms in the road at the level of detail that we're now getting into in real life, right? So we're putting to the test. We can have these very broad statements on use of space, celestial bodies and resources and things like this, and rules of the road. But we really need to come into our own on understanding what are the rules of the road in low Earth orbit, in deeper space, et cetera, for very specific contingencies. I think that we should talk about. One of the things we talked about in our article on this front, which is this idea of space debris and space junk. For the past 60 years plus, we've had a situation in which there has been an increasing proliferation of, not for malign purposes, but just by virtue of the technical reality of the situation, where spent rocket parts, old satellites, defunct satellites, broken off pieces of satellites, and other space vehicles are increasingly creating a what would be considered a hazard to navigation in a UN Law of the Sea category. I mean, imagine if after using a cargo vessel going across the ocean, you just kind of pushed it back out into the ocean and let it float around and break apart. This is exactly what's happening above our heads right now, and the increasing collision of objects in space with others are creating a exponentially increasingly large debris cloud that is creating a hazard to future space travel, both manned and robotic and satellite based. And so what we need to do is understand how can we stop the bleeding. How can we get to a point where we're not contributing to the exponential proliferation of these objects, which can damage and imperil the ability of future missions to be successful, and not create what has been called a prison for humanity, right? Where we're in the worst case scenario, this just continues to go unchecked, and you create such a thick debris cloud around the Earth that's moving at such a velocity that it basically imperils any chance of a successful mission beyond low Earth orbit, and we are stuck for many generations until these objects that have not been deorbited or left in a suborbital trajectory, et cetera, in a proper way, are basically taken out of low Earth orbit. And so we don't want to get to that point. I think that's a really good area to start from for an international norms and international agreements that we need to focus on sooner rather than later. And all entities, whether you have this growing divide between the Russia-China moon base and those sort of discussions, and the Artemis Accords and that sort of thing. Everyone is going to be impacted by this, period. And so that's why it needs to be addressed and addressed soon.
So just to sum up, and I completely agree with this. First, we've got to have norms of behavior, because I don't see a treaty on the horizon for space debris, but we have to have norms of behavior to frankly stop the bleeding. And then you decide what you can do positively to prevent further damage, but we've got to stop the bleeding. So the treaty system is inadequate. It's not because it's wrong or somebody made a mistake, it's because things changed. And therefore every treaty has to be updated to meet the changed conditions. Then there has to be a disarmament discussion. The NATO policy is that it has no intention of putting weapons in space. That's a very clear statement. And yet the control of conventional weapons in space is not subject to international agreement. And so that is a prime purpose for us here today and for encouraging this discussion. And as Ben says, it is coming unless you do something about it. In international diplomacy, if you have a problem, it gets worse and worse until you decide to do something about it. And then finally, of course, there is the framework that I mentioned of 30 NATO states, 27 EU states, Japan, South Korea, Australia, which form an important and powerful force in the world economy and in global security that has a generalized agreement about how to approach these problems. So let's see if we can find some common ground with China and Russia in this area, as we did with Russia in the nuclear disarmament area, where we might be able to attenuate the risk for the benefit of all.
And I'll add to that. I mean, what was the impetus for our article in Foreign Policy last month was the headlines that I think captured really the entire world of the Chinese Space Agency launching a module of its new space station with a Long March 5B rocket, who basically did not have a suborbital trajectory, meaning the base stage of that rocket didn't have a path that would not take it up into low Earth orbit. And so if it had a suborbital trajectory like a lot of NASA or some SpaceX vehicles do for their lower stages, they can come down. You've seen obviously SpaceX actually land its lower stages for reuse on drone chips out in the sea. This didn't have that, and it also didn't have thrusters to deorbit burn that lower stage of the rocket module of the Long March 5B rocket module into either burning up in the atmosphere or controlling where it would come down, so it was coming down in an unpopulated area. Often the South Pacific is used as a kind of a dump for some of these spent rocket parts. And instead, we had an entire week of the entire global community having headlines every day of is there a risk of this actually the sky actually falling on us, right? Is there a risk that this will fall in a populated area? And thankfully it didn't. In this case, it landed several hundred miles west of India in the Indian Ocean. But in the past, about a year ago, parts of a Chinese rocket actually fell on the Ivory Coast and damaged structures there, which thankfully there were no fatalities and didn't actually harm anyone and have casualties on the ground, but it could have. And so even though the risk is low, just because of the statistical risk of hitting a populated area may be low, it's not zero. And if it's not zero, we need to have specific rules and regulations that enforce how these sort of lower stage rockets are dealt with, both so that they don't harm the populations on the ground or structures or property on the ground, and also don't break apart into creating a further hazard to navigation in terms of a field of space junk in low Earth orbit.
I'm really glad that you brought that up, Ben. As an astronomer, I'm well aware of kind of the stakeholders in these conversations that are ground-based, right? I think a lot of people think that space diplomacy is really a conversation between countries who are space capable. But there are many living oral cultures around the globe who use the stars to preserve traditional knowledge. In countries like our own, we have major investments in basic research that are reliant on ground-based telescopes to answer big questions about our origins. And these are investments that are being threatened by satellite trails, which are increasingly problematic and unregulated and brighter than ever. So I wonder if you could talk a little bit about the stakeholders who will be at the table, ideally in these space diplomacy questions, and to also to not dismiss a great question that came in that's related from the Q&A. Dr. Elizabeth Colton writes, as a former U.S. Foreign Service officer who enjoyed assignments in the Bureau of OES, the Oceans, Environment, and Science, with its portfolio including space diplomacy, I'm wondering how widespread or possibly universal is this, quote, space diplomacy, part of all other nation states' diplomatic portfolios now in 2021? How active are non-big power nations in participating in space diplomacy discussions? And does the United Nations encourage participation by all nations today in space diplomacy? Much appreciation for this webinar.
I would just say, in answer to the ambassador's excellent question, the last three answers are yes, yes, and yes. The UN encourages global participation. NATO shares with its 30 members. The EU shares with its 27 members. Japan, South Korea, and Australia are part of this complex. So a lot of this information is being shared. The ambassador is exactly right about the bureaucratic organization of the issue. One of the things we're pushing at Duke is the integration of scientific knowledge and diplomacy. These two disciplines have not collaborated sufficiently, and I would think that, and now it's absolutely essential that we be allowed to do so. There is no department there's no office in the Department of State that has an executive function or reporting to the Secretary of State directly on space. So one of our earlier articles in The Hill this last year, I think in October, was designed to specifically call attention to the fact that we have to have a space component and a science component at the very highest levels of the State Department, as well as other agencies, to be able to manage this problem. So on the bureaucratic side, we need a space envoy, and we need someone with bureaucratic, budgetary, and executive responsibility to help coordinate these issues.
Yeah, I absolutely agree. NASA has a lot of those functions already, but we need more of a proliferation of a space envoy or space envoys, space diplomats throughout our entire diplomatic portfolio. Because if we don't, we risk missing the interplay between space policy dynamics and other areas of U.S. foreign policy and national security. I will get back to Britt's question in just a second, but I do want to mention, just because that came up, there are, for example, the interplay between space policy, space diplomacy, and traditional national security and sanctions policy. Dmitry Rogozhin, the head of Roscosmos, who himself is under sanctions, stemming back to his time as deputy prime minister, is under sanctions as a part of the U.S. and European response to Russia's illegal annexation of Crimea and aggression in eastern Ukraine. And at the same time, in those sanctions packages, there are sanctions on space technologies. And increasingly, Roscosmos has admitted, including in the past few weeks, that it is being impacted on a very real basis by these sanctions, which is interesting from the transatlantic security watchers community to hear, because oftentimes Russia will say that they try to downplay the efficacy of unified sanctions policy. And Dmitry Rogozhin has come out just earlier this month in St. Petersburg and said very clearly that although we may have the rocket engines to launch our vehicles into space. There's increasingly a limitation on some potential dual-use technologies that they no longer can import because of these sanctions. So those sort of interplays need to be addressed and need to be recognized. And we can get back in just a second. Hopefully, we can talk about the International Space Station, because I think that's a great test case in a moment. But I do want to answer the question, Britt, that you posed on cultural heritage. I did my PhD on a telescope that was looking at the oldest light in the universe, the cosmic microwave background from northern Chile in the northern Atacama Desert up at high altitude near the Bolivian, Argentinian, and Chilean borders in Chile. And part of that experience really taught me that the Atacameño culture, for example, in the region is very, very tied to, in terms of its cultural heritage, to the cultural heritage of the night sky and of celestial observations and things like this. And that's why part of our programs and the programs that I was involved with and that are still ongoing is interfacing directly with those stakeholders and interfacing with having the Chilean government and interfacing with them directly. And that's why they created this Parque Astronómico de Atacama. I don't speak Spanish, so I think I'm getting that close to right. But apologies to folks if I didn't. But that take into account those sort of things, and that is really key to this discussion on CubeSats, and in particular the increasing proliferation and deployment of the Starlink systems. And I actually would love to hear your thoughts on this, Britt. But I would also say it is an impact on ground-based astronomy, of which the international community has invested literally billions over decades in various parts of the earth. And although there have been some technical mitigations that SpaceX has done to help out the ground-based community to not be completely bogged down in their time streams of looking at the sky for some period of time and then seeing these small CubeSats streak across their images by putting things, for optical telescopes like star shades, basically a absorptive surface around those CubeSats. That doesn't work for all areas of the electromagnetic spectrum. In areas, for example, in the field that I'm in millimeter wavelength astronomy, there isn't a recognition in that and other areas of astronomy that these can be an issue and something that we need to work together and have astronomers themselves, scientists themselves, part of that discussion from a technical point of view. If we're going to save the skies to be used for ground-based astronomy in the future, because we've really been able to expand our understanding of the early universe, the evolutionary history of the universe, and really quite literally our cosmic origins in the primordial universe by having good access to the nighttime sky from the ground. And although, yes, you can say, well, you can always send telescopes up into orbit, and that is true from a technology development standpoint, from a deployment standpoint. You can do a lot of technology development and testing and great science from the ground that we really just can't abandon, obviously. So these have to be issues that astronomers are part of the discussion as well. Scientists part of the discussion as well, and I think SpaceX has started to engage, especially with obviously the optical astronomy community, and I think it's going to have to continue throughout the entire astronomy community worldwide. But Britt, what do you think? Because you've thought a lot about this.
Well, I don't want to grandstand too much on this, but it is a problem, right? And major upcoming observatories that we have invested a lot in actually will be impacted in a real way. And maybe most people don't care about whether or not we answer these questions about our origins on cosmic timescales, but maybe people care about detecting asteroids that could endanger civilization, right? And those are actually things that we oftentimes detect at twilight times of the evening, which is when these satellite mega constellations are actually most problematic. They're brightest at those kinds of times of low light. So I think it's something that, should not be seen as an abstract, trivial concern. I think there's good reason to regulate these that is relevant to most people. I know we're short on time, so there are a couple of points that I think we should cover. One question that's come in from the Q&A is, where in this picture does the US Space Force fit? And I would also love to hear your comments on the International Space Station and whether or not, in your view, that is an example of successful space diplomacy.
Yeah, let me talk to the Space Force. The Space Force is very important in this picture because its policy is integrated with the NATO policy. So the fact that we have an alliance which has explicitly referred to defense and deterrence means that the Space Force has a critical role. The Space Force, like any military force, is both designed to win if there's a conflict, and it's designed to deter a conflict if at all possible. So that's a critical part of our process, but it's not the entire process. The entire process, just like it was with nuclear weapons, is to find a way to manage the competition that inevitably does result. So I don't know, we may not have time for final remarks. So I would just like to say, if there's anything you remember from my talk today, it is that there are a number of complications which create a sense of urgency. But let's don't fail to see the forest for the trees. We have a process. We have three processes. We have the norms of behavior discussion. We have the disarmament discussion, which means managing to our benefit the results of activities in space which threaten us. And thirdly, we have a complex of nations around the world which share general values and general approaches which are ready to help create a conversation that will also affect what happens at the UN. So those three processes, I think, are important to keep in mind. And for policymakers who might be listening, it would be really important to see how to breathe life into those so that we can solve a problem now. It took 10 years to get the first nuclear disarmament treaty. It took about 10 years to get the Antarctic treaty negotiated. There's no such thing as waiting until it's needed. It's needed now. So starting that process now will be a benefit to us later. Thank you very much.
Yeah, absolutely. And I mean, that's what we talk about a lot in our program, which is anticipatory diplomacy, which is a hallmark of space diplomacy in this case, because, future technology deployments and systems will have unexpected consequences as they interact with each other in an increasingly large area of space, of different areas of space, and we need to keep that on the radar. I think that, to your question on the International Space Station, it absolutely was and continues to be a hallmark of international cooperation on how space diplomacy can and ought to work. But we're getting to the end of its life cycle. I mean, there's discussions of mid to late of part of this decade that it could be decommissioned. I know that the Trump administration and the Biden administration both have put out different timelines for that. But we are getting to a point in time where it is not the only show in town anymore. As I mentioned earlier, the Chinese have just launched and as of last month, a module of their own national space station, and have had their first crew show up just a few days ago. And so the question is, how will international cooperation on the human presence in low Earth orbit in terms of space stations continue? And really, what we're seeing right now is the result of something that has been slow moving but predictable for the past 10 years. So we had you have to kind of look at the two timelines, the space technology timeline and the geopolitics timeline. We're talking about U.S., in this case, I'll give an example like U.S. and Russian cooperation in human space flight, where you had the U.S. decommission its space shuttle fleet about 10 years ago, and so basically, there were dual launch capabilities, meaning that the Russian Soyuz and the U.S. space shuttle from the early days of the space station, so from the late 90s through 2010, let's say, were both launching, and then the U.S. no longer had that capability. In that decade, the geopolitical situation was much different than it is in the following decade between the U.S. and Russia. Russia became a much more malign actor on the world stage, especially after its ingress into Ukraine in 2014. So that has changed, but the U.S. relied on buying seats from Roscosmos on their Soyuz launch vehicle to get joint crews to and from the International Space Station, while the U.S. didn't have its own launch capability. And what we're seeing now is Roscosmos, due to sanctions, losing a significant portion of its budget, meaning that it went from about $5 billion dollars in annual budget in 2014 to about 1.7 in the past few years. And a major part of its revenue stream was the U.S. buying seats on Soyuz rockets. That's no longer the case. And NASA has said that in the future, they would like to have in-kind contributions to one another. So kind of reciprocity where Russian cosmonauts can trade seats with the U.S. and vice versa between SpaceX launch vehicles and Soyuz capsules in the future. But that's getting rid of a significant budget line item for the Russians themselves. So they're looking towards working with the Chinese potentially in the future on this front. But at the same time, we saw the Russians request and be in talks with the Chinese to launch their space station at a higher inclination angle with respect to the Earth, or else it would limit the access of direct space launches from Russian facilities to that space station. And the Chinese did not do that. So it's a question of what is this going to look like from a technical point of view? And again, we want to avoid a new Cold War, and we want to avoid a new space race. But de facto, some of these dynamics are coming back into play. And it's coming into a play where we don't just have two actors, we have a very, wide array of actors. And I again, one of the questions that was raised are in the Q&A feature was, other sized powers. So we're not just talking about the US, Russia, and China in this case. We're talking about mid-sized geopolitical powers. The United Arab Emirates was, the first nation of let's say that scale, that economic scale, to launch a vehicle all the way to Mars and do it successfully. And so they're part of that discussion. So this is a much broader discussion set, and that's why I guess I'll leave this as a trailer for discussions to come. We're not going to be done in the Duke Rethinking Diplomacy program talking about this today. This is kind of to hit the tip of the iceberg on all of these sort of issue sets, and we'll try to do more deep dives into each one of these different topics in the coming months ahead as we try to talk about the sort of diplomatic solutions with key stakeholders to these problems.
All right. Well, thank you both. I think we're just over time, so I might hand it back to Giovanni.
Thank you, Britt, and thank you, Bob and Ben. This has been a great discussion, and I know that there are a lot of questions that we did not have time to address, but as Ben just mentioned, we will address them in the future. So stay tuned, and thank you again to our moderator, Professor Britt Lundgren, and see you soon. And thank you to the Duke NDC and the Rethinking Diplomacy program for bringing this panel together. Thank you, and see you soon.